Are you all ready to travel in space? Say yes. Okay, in case you said no, you're already traveling in space. And this is your spaceship. So we are starting here. This is our spaceship, Mother Earth. And it's a great place to travel in space, in the solar system. It has great air conditioning, and you are protected from the space conditions, from the atmosphere, and by the magnetic field. So it's the place in which humanity has evolved. We all evolve here. And we evolve in the presence of resources. So all life on Earth has been developed through water, air, food, so everything that is available in what we call the biosphere, in which also the wastes are somehow destroyed by microorganisms and transformed into something else. And this is a great source of inspiration also for space missions. So the Earth is the cradle of humanity, but you cannot stay in the cradle forever. It's not my sentence, it's the sentence of Tsiolkovsky, a visionary, a century ago. So at a given point in time, we decided that as humans, we want to explore space, which is not easy. It's not easy at all. But we wanted to go there. So 60 years ago, we decided to go to space. And 50 years ago, we were on the moon. So we have started our space adventure as humans. And in the next centuries, this generation will be reminded as the space generation. Maybe everything else will be forgotten, but this will not be forgotten. We are the space generation, and we have to be proud of it. And we are very, very proud to say that now we are in space at low Earth orbits. This is our frontier now. The space station, the International Space Station, a great international endeavor and project in which we have had the ability and the fortune to build a lot of it. So about 40% of it was built by Thales Space, different modules and systems. I will show you now. And we are now close to 500,000 hours of flight for all our systems without any major failure. So we are really, really quite proud of it. And when you look at the station is made of different systems. Some of them are permanent on the station, so what we call pressurized modules, like the Node 2 and the Node 3, in which astronauts have, for example, their living quarters, and where we have our life support systems. And this is by far the most complex that we build, because it interconnects 6 other modules. You know, the station is like a Lego system. Everything is put together like in a Lego. And then our second and last generation of modules that we are flying about twice a year is called the Cygnus. So it's a smaller system, and this is used to resupply the station. So, you know, astronauts to live there need resources, and experiments need to be brought on station, because the station is used to perform research and development in the absence of gravity. A very, very special environment. And now on Earth, we have gravity, and up there, we remove it. So we can really study phenomena in a very, very different way and unique way. And with the Cygnus, we fly water, food, garments, whatever is needed for the astronauts. And what we can say is that in the last 20 years, we have really learned how to have humans survive and stay well and be productive in space. So environmental control systems, but also the life support. Just consider that astronauts are very, very conscious about their resources. Sometimes we are not as much as they are. Consider, for example, the case of water. We, as Europeans, more or less consume 200 liters of water per person per day, which is a lot. Astronauts on the station, 3 liters. So first rule, use well your resources, but also those 3 liters are continuously recycled. So what they say is that the coffee of today is also the coffee of tomorrow, which might sound not great for after lunch, but it's like that. And what is next? What we learn from the station can be brought further in space in exploration. So the next step will be the moon, orbiting the moon, the so-called gateway. This will be used for helping us going into deep space towards Mars, and also to build infrastructures on the surface of the moon, like a new outpost. After 50 years, we'll go back to stay and to build a base, to build in the future maybe a village, something much larger than what was in the past. But really, the interesting destination in the solar system is Mars, not only for humans, but for robotic missions first. And why is Mars interesting? Maybe you know. It is similar to the Earth. It has an atmosphere, although it is a thin atmosphere. It has water, as it was discovered by our radars in previous missions. There is liquid water under the surface that can be exploited by humans in the future. And so what are we doing there? First, we go with robots and automatic missions. This is the ExoMars. We had a successful mission in 2016 to bring a satellite orbiting Mars in order to study its atmosphere and to do data relay to Earth for future missions. But the really interesting one will be next year, 2020, ExoMars, launch in July. Stay tuned. We are going there with a big rover to go on the surface of Mars and study life precursors, which could be under the surface. So there will be a drill that will take samples under the surface and analyze it in a very special lab, which is inside the rover. Is it a Mars desert or an Earth desert? Okay, I tell you, we don't have a lot of time. This is a Mars desert, but does it really look like maybe an Arizona desert, Utah desert? Yes. So very similar. And this is an Earth desert. So extreme conditions, extreme environments exist everywhere in the solar system, not only on Mars, in space, but also on Earth. And maybe in the future we'll see more of that. We hope not, but it will probably happen. And still, we want to go there. We want to explore, and we want to explore not only hot and arid places, but also Arctic, other places. So for those reasons, we are developing new systems. If you go to the poles, you can make nice encounters. You see these two guys, and this is a mission that we accomplished in Antarctica. It's called the Eden ISS, a project funded by the European Community. That module contains food production systems, so plants grow in extreme environments, in artificial environments, just like in space. And there is a common denominator, and I'm going to finish. You can show a video that will illustrate the Piume solution. So actually, I'm not going to say much about that. Portable independent utilities for extreme conditions. You see that extreme conditions can be deserts, can be the poles, can be space, and in any case, you need to provide resources to people. So you need water, you need power, connectivity, health management, and everything. And this is the solution that now we have developed, starting from space, but we are deploying to the Earth. You can try it at our VR demo there, so I'm not going to spoil it too much. If you need more information, we are glad to tell you. And when you have to contend with extreme conditions, our integrated Piume solution helps you survive. Space for life. Thank you.